Forget the grainy black and white footage. Forget the stories of flags and footprints. The real race for the moon isn't in our past. It's unfolding right now, in secure planning rooms at NASA, in Beijing, and in the boardrooms of the world's most ambitious private companies. For decades after Apollo, our ambition retreated to low Earth orbit. The space shuttle was a marvel, but it tethered us to our home. The moon, once a destination, became a distant, silver memory in the night sky. But that silence is over. This is a new Genesis. A strategic gambit is being played out on a scale we've never seen. The board is set. The pieces are moving. The moon has become the most valuable, unclaimed piece of real estate in our solar system, and a new, silent space race has begun. But this time, the prize isn't just national pride. It's about resources that could power our future on Earth. It's about strategic positions that will control the access to deep space. It's about who will write the rules for the next frontier of humanity. The question is no longer if we are going back. The question is who will get there first, and what will they control when they do. The stakes have never been higher. On one side of the board, you have Team Artemis. Led by NASA, this is a global alliance of nations, now numbering over 40 countries, all signatories of the Artemis Accords. It's a vision of an open-source model for space exploration, built on interoperability and shared scientific discovery. Their strategy is a masterclass in public-private partnership. NASA sets the grand objectives and builds the deep space transport, while contracting private industry titans like SpaceX to compete on building the critical human landing system, a model designed to foster innovation and aggressively drive down costs. On the other side, you have the formidable China-Russia alliance. They have rejected the Artemis Accords, viewing it as a U.S.-centric framework, and are developing their own rival project, the International Lunar Research Station, or ILRS. Their model is more centralized, state-driven, focusing on a methodical, robotic-first build-out. It's a quieter but no less determined approach to establishing a long-term foothold, actively recruiting their own international and commercial partners. It's a clear divergence of philosophies, a direct competition for influence, resources, and the allegiance of emerging spacefaring nations. And what are they competing for? A prize beyond measure. First, water ice. It's not just water. In space, it is white gold, the oil of the solar system. For billions of years, cometary impacts delivered this water, and in the absolute cold of the permanently shadowed craters, some of the coldest places in the entire solar system, that water has remained, a frozen, pristine record of cosmic history. With solar power, you can perform electrolysis, splitting H2O into breathable oxygen and liquid hydrogen and oxygen, the most powerful chemical rocket fuel we know. Whoever masters this process on the moon controls the gateway to Mars and beyond. Then, there's helium-3. Bombarding the lunar surface for eons, the solar wind has deposited this rare isotope, which is incredibly scarce on Earth due to our protective magnetic field. Helium-3 is the dream fuel for clean, aneutron nuclear fusion, a process that could, in theory, power our entire planet for centuries with almost no radioactive waste. It is, quite literally, a buried treasure of unimaginable value. Beyond that, the lunar soil is rich in rare earth elements like scandium and yttrium, critical for everything from our smartphones to advanced defense systems. And finally, there's the real estate itself, the peaks of eternal light on crater rims, where solar panels can receive near-constant sunlight, providing limitless energy for a permanent base. These are the strategic high grounds of the 21st century. This new race is defined by new rules and new tools. The rules are being shaped by the Artemis Accords. They champion principles like transparency, the peaceful use of space, and the public release of scientific data. But the core of the debate centers on Article 11, which allows for the creation of safety zones to prevent operational conflict. To its supporters, it's a necessary rules of the road to avoid chaos. To its critics, it's a loophole, a first step towards a de facto claim of territory on a celestial body that is supposed to be the province of all humankind. This legal and ethical gray area is a source of deep international tension. But the true game changer, the technology that makes this all possible now on an industrial scale, is reusable transport. Specifically, SpaceX's Starship. This is not just another rocket. It's a paradigm shift. A vehicle designed to be fully and rapidly reusable, capable of delivering over 100 metric tons of cargo and crew to the lunar surface in a single trip. To put that in perspective, the tiny Apollo LEM could only support 2 astronauts for 3 days. Starship aims to support dozens for months. It changes the entire economic equation, making the construction of a permanent, self-sustaining base financially feasible for the first time. And once there, a new technological ecosystem is emerging. That lunar 5G network isn't for astronauts to stream movies. It's the nervous system for a robotic workforce, allowing for real-time, high-bandwidth control of rovers and mining equipment from a habitat or even from lunar orbit. And robotic 3D printers, using a process called sintering, can melt the lunar regolith into a ceramic-like material, building landing pads, shelters, and radiation shields with local materials. This isn't science fiction anymore. This is the engineering roadmap for the next decade. With these breakthrough technologies, what do you think is the biggest challenge the next generation of astronauts will face? The harshness of the lunar environment, or the complexity of living and working in a multinational, multi-company environment? Please leave your opinion below. We stand at a crossroads. The moon, our silent celestial companion, is about to become a bustling hub of human activity. The technologies are here. The resources are confirmed. The political and economic will has been ignited. For the first time, a permanent off-world presence is not just a dream, but an active engineering project on the verge of reality. Humanity has a long, often troubled history with frontiers. We have explored, but we have also exploited. We have cooperated, but we have also competed. The moon offers us a clean slate, a chance to write a different kind of history, to prove we've learned from our past. But this new frontier presents us with a choice, a reflection of our own species. Will the moon be a model for a new era of global collaboration? A place where humanity can work together to solve challenges that benefit us all? A stepping stone to Mars for everyone? Or will we simply export our earthly competitions and conflicts to the silent dust of another world, drawing new borders in the sky? The race is on, and the rules are being written in real time. And the outcome will define not only the future of space exploration, but perhaps the future of humanity itself. The silence is about to be broken. The question is, what will we say when it is?